Question 1. A set of 15 scores is displayed in a stem and leaf plot. What is the median of these scores? Now it's an odd number of scores, so if we divide 15 by 2, we get 7.5. Round that up to the nearest whole number, and the median is the 8th score. So let's count 8 from the very beginning. 1, 2, 3, 4, 5, 6, 7, 8. So the median is 78. So you take the stem, combine it with the leaf, 78, option D. Question 2. Handmade chocolates are checked for size and shape. Every 30th chocolate is sampled. Which term best describes this type of sampling? Let's go through the options. A census means every chocolate is sampled. This is every 30th chocolate is sampled, so it's clearly not a census. Let's check B, random. Well, every 30th chocolate is sampled, so it's clearly not random either, since it's every so many chocolates, one is sampled. So it's not A, it's not B. Stratified, well, that applies to ensuring if there's multiple groups that there's a fair representation of each group. But we're just talking about one group of chocolates here. And it's every 30th chocolate. So the answer is D, it's systematic, since there's a system of sampling where every so many chocolates, one is sampled. So it's option D. Question 7. The pie company has 2 bakeries. The radar chart displays the monthly sales for the bakeries. What was the difference in sales in June between the 2 bakeries? Now the first thing to note is that the monthly sales is in thousands of dollars. Next, let's locate June and work out the difference between bakery number 2, which is a solid line, and bakery number 1, which is the dotted line. So bakery number 2 corresponds to 35,000. And we're going to subtract from that the monthly sales for bakery number 1, which lies in between 20,000 and 15,000. And that's 17,500. And that equals 17,500. So it'll be option D. Question 28D. The test results in English and mathematics for a class were recorded and displayed in the box and whisker plots. Part 1. What is the interquartile range for English? And that's just found by taking the third quartile and subtracting from that the first quartile. So 80 minus 50 is equal to 30. Part 2. Compare and contrast the 2 data sets by referring to the skewness of the distributions and the measures of location and spread. Let's consider skewness. For English, the lower tail is much longer than the upper tail, and the median is much closer to the maximum score as it is to the minimum score. So we can conclude that the scores for English are negatively skewed, whereby with mathematics, the length of the 2 tails are approximately equal, and the median is roughly halfway between the minimum score and the maximum score. So we can conclude that English is negatively skewed in comparison with mathematics, which is approximately symmetrical. Let's consider the interquartile range and the range for English and mathematics. So interquartile range for English is 30. We worked that out from part 1 previously. And the range is 85, so from 10 to 95. For maths, the interquartile range is 15. So that's from 65 to 80, and the range is 40, so from 50 to 90. Now the lower interquartile range and range for mathematics may indicate more consistent scores in mathematics when compared to English. Now let's consider the medians. So the median of both is approximately equal to each other. There's not much in it. So the median for English is 70 and the median for mathematics is 75. So we could say that so the middle part of the distribution, or the center score, or the center scores, are roughly equal to each other. And one other point to compare is the fact that quartile 3 for English is equal to quartile 3 for mathematics. So the 2 upper quartiles are identical as well. So the top end, or the upper 25% of English, is roughly equal to the upper 25% of scores in mathematics. So there's quite a bit there that you can consider when writing your response to part 2. Question 6. A survey was conducted where people were asked which of 2 brands of smartphones they preferred. The results were 48% preferred brand X, 52% preferred brand Y. A graph displaying the data is to be included in a magazine article. The editor of the magazine wishes to ensure that the graph is not misleading in any way. Which graph should the editor choose to include in the article? So if I have a look at option A, we can see that the y-axis does not begin at 0. So option A is misleading, so it cannot be included. And for the same reason, option C cannot be included because its y-axis also does not begin at 0. So option C is out. So that leaves us options B and D. So we can see that with option B, the width of the columns is not consistent. So option B is misleading. So that leaves us option D as the only viable choice. But we can see that the y-axis for option D begins at 0 and the width of the columns is consistent. So option D is the answer. Question 8. A high school has 100 students in each year group, year 7 to year 12. A survey is to be conducted to determine the average number of text messages sent per month by students at the school. Which of the following would provide the most representative sample for this survey? Now we need to choose a sampling method that ensures as much as possible that each year group is fairly represented. Now since each year group consists of 100 students, so each group is exactly the same size, we need to pick a sample from each year group such that each of the sample sizes are identical. So if we choose 10 students from year 7, we need to choose 10 students from year 8, 10 students from year 9, and so on. So the sample size from each group needs to be identical as well. So options A and B are clearly out. Option D is out in fact, because this doesn't ensure that the sample chosen from each year group is going to be identical. So that leaves us option C, 20 students chosen at random from each year group as the most representative sample. So the answer is C. Question 14. The July sale prices for properties in a suburb were $552,000, $595,000, $607,000, $607,000, $682,000 and $685,000. On the 1st of August, another property in the same suburb was sold for over $1 million. If this property had been sold in July, what effect would it have had on the mean and median sale prices for July? So we're going to add another score that's much larger than the existing scores and then take the average of that. So clearly $1 million being much larger than all the others will increase the mean. So the mean will change. But let's see what happens to the median. So currently we have 1, 2, 3, 4, 5, 6 scores. So it's an even number of scores. So the median will be the average of the 2 middle scores. Since these scores are in order, we don't have to sort them. So the average of 607,000 and 607,000 is just 607,000. So if we add an extra score, so let's add this pronumeral X here to represent $1 million. We have 7 scores, so 1, 2, 3, 4, 5, 6, 7. The median now, because it's an odd number of scores, the median is the 4th score. 1, 2, 3, 4. So the median is still $607,000, even though we've added this extra $1 million. So the mean has changed, but the median has stayed the same. So it's option C. Question 15. The frequency histogram shows the number of goals scored by a football team in each game in a season. What was the mean number of goals scored per game by this team? So I'm going to use the stat mode on the calculator to enter in this data, and the calculator will work out the mean for us. So if we press mode and then stat, 1 var, so number 1, you notice that we have a column for the scores but no column for the frequency, so we need to enable that in this calculator. So shift mode, so that takes us to our setup screen. Scroll down, number 4 stat, if you press that, frequency on, so number 1, you can see now you have the frequency column. So let's enter in this data. So 3 goals scored, 4 goals scored, 5 goals scored, 6 goals scored, 7 goals scored, and 8 goals scored. So scroll across to the frequency column. and the number of games where 3 goals were scored was 3 games. 4 goals scored, there was 7 games. 5 goals scored, there were 5 games. 6 goals scored, there was 1 game. 7 goals scored, no games. And 8 goals scored, there were 4 games. Now press AC and then Shift 1 to bring up our stat menu, and then number 4 var, and number 2 X bar, and equals, and we get 5. So the answer is option C. Question 26b. Write down a set of 6 data values that has a range of 12, a mode of 12, and a minimum value of 12. So let's work backwards. Let's start off with the minimum value of 12. So that means the first score in this set of 6 scores is 12. Now let's consider the range. Now the range is 12. So that means the difference between the maximum and the minimum value is 12. So if the minimum is 12, that means the maximum must be 24. Now for the numbers in between. The set of 6 data values has to have a mode of 12. Now the mode represents the most common score, or the most popular score. So we have a range of responses here. So we know that the number 12, or the score of 12, has to be the most common. So perhaps I could write a second 12 there. But there's nowhere in the question that states that the scores have to be different or distinct. So I decided one response could be just fill the middle 4 scores with just the number 12, or the score of 12, and that answers the question. You could have another response, for example, 12, 12, 13, 14, 15, 24, that will answer the question, or any set of numbers in between such that all 3 conditions are satisfied. Question 26F. Jason travels to work by car on all 5 days of his working week, leaving home at 7 AM each day. He compares his travel times using roads without tolls and roads with tolls over a period of 12 working weeks. He records his travel times in minutes in a back-to-back stem and leaf plot. Now what I've done already is I've annotated this back-to-back stem and leaf plot. I've calculated the range and also the shape of the distribution for each side of this back-to-back stem and leaf plot. We will need this for part 3 of this question. So part 1, what is the modal travel time when he uses roads without tolls? Now the answer is 52 minutes. So how do we get 52 minutes? Let's refer to this side of the back-to-back stem and leaf plot, so without tolls. We look for the leaf that occurs the most often, sort of one after the other. And we can see here that the number 2 occurs one after the other most often. So this occurs 4 times in sequence. So combining the leaf with the stem of 5, that gives us 52 minutes. Now part 2, what is the median travel time when he uses roads without tolls? Now there are 30 scores on this side of the back-to-back stem and leaf plot. It's an even number of scores, so if we divide that by 2, we get 15, which means the median is the average of the 15th and 16th scores. So counting 15, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So that's 50 and 51. We need to take the average or the mean of 50 and 51, which is 50.5. Hence the median travel time is 50.5 minutes. Now part 3. Describe how the 2 data sets differ in terms of the spread and skewness of their distributions. So first of all, if we consider the spread of scores, we can see clearly that without tolls, it's quite narrow. And calculating the range, so that's 61 minus 39, we get a range of 22 minutes. If we compare that with the range of with tolls, or travel time with tolls, we get a range of 55 minutes. So that's 90 minus 35. So clearly, the spread of scores is much greater with tolls compared to without tolls. Now looking at the skewness or the symmetry or lack thereof, we can see that without tiles, the distribution's fairly symmetrical. But with tiles, we can see that the distribution is positively skewed. So there's a tail here on the sort of the positive side of this distribution where the numbers are greater or the scores are larger. And they seem to be bunched, or the scores seem to be bunched more toward the negative side. However, it's positively skewed because we look where the position of the tail is. In fact, if I turn the back-to-back stem and leaf plot around, we can see here that the tail is toward the positive side of this distribution, or toward on the scale, the positive side of the scale. So in answering this question and wording the question, you will need to take into account these facts. Question 27C. A retailer has collected data on the number of televisions that is sold each week in 2012. He grouped the data into classes and displayed the data using a cumulative frequency histogram and Polygon ogive. So part 1, use the cumulative frequency polygon to determine the interquartile range. So I've done part of the solution here, so I'll explain what I've done. The first thing to determine is the total number of scores. And we get that from the end of the polygon here, or just the height of this column. If you project across to the y-axis, we see that corresponds to 52. Next, we need to divide this data into quartiles. So if 52 is the number of scores collected, then 1/4 of 52 would correspond to the first quartile, and 3/4 of 52 would correspond to the third quartile. So 1/4 of 52 is 13, and 3/4 of 52 is 39. Next, we project across from 13 and 39 until we strike the ogive, and then project downwards to work out what the 13th and the 39th scores would correspond to. So the 39th score is 470, the 13th score is 190, and the difference between 470 and 190 would then be the interquartile range, which will be 280. And part 2, Oscar said that the retailer sold 300 televisions in 6 of the weeks in 2012. Is he correct? And give a reason for your answer. Now, if we go back to the question, it says he grouped the data into classes. So we don't know precisely whether 300 televisions were sold or not. That's the group, but it doesn't necessarily mean that that corresponds to exactly 300 televisions sold. So he's incorrect. Data is grouped, which means that individual or specific weekly sales cannot be determined with any degree of accuracy. And the class center of 300 includes sales from 250 right up to 349 televisions per week. So we've got to understand, or sort of remember, that 300 really represents a group and not a particular number of units sold. Question 1. The step graph shows the cost of telephone calls to China. Bella made a telephone call at 9:50 p.m. to a friend in China and spoke to him until 10:07 p.m. How much did this telephone call cost? Now, the x-axis of the step graph represents the length of time that the phone call took. So in this case, from 9:50 p.m. to 10:07 p.m, that's 17 minutes. And one easy way to work that out is 9:50 p.m. to 10 p.m. is 10 minutes. And from 10 p.m. to 10:07 p.m. is another 7 minutes. So again, that makes it 17 minutes. Let's locate 17 minutes on the x-axis. So somewhere midway or between 15 and 20. So maybe approximately there. And if we take a ruler and project upwards, we can see clearly which step the vertical line is going to strike. So it strikes the top step, and that top step is the $16 step. So that's the step from 15 minutes onwards. So the answer is D. Question 14. 20 Year 12 students were surveyed. These students were asked how many hours of sport they play per week to the nearest hour. The results are shown in the frequency table. What is the mean number of hours of sport played by the students per week? Now, because we're dealing with class data, we need to find the midpoint of each of the classes first. So the midpoint of 0 and 2 is 1, the midpoint of 3 and 5 is 4, 6 and 8 is 7, and 9 and 11 is 10. Next, we can use the stat mode on the calculator to determine the mean. So mode and stat, so let's press that. and one var, so only dealing with one variable statistics. Notice that we don't have a frequency column, so we'll bring that up by pressing Shift, Setup, scroll down, and then number 4, stat, and frequency on. Now we can enter in the data from the table. So I'm going to enter in these midpoints first. So 1, 4, 7, and 10. Next, I'll enter in the frequency of each of these classes. So 5, 10, 3, and 2. Then press AC, Shift 1, and then number 4, var, and then option number 2 for the mean, and we get 4.3. So that's option B. Question 26E. The times taken for 160 music downloads were recorded, grouped into classes, and then displayed using the cumulative frequency histogram shown. On the diagram, draw the lines that are needed to find the median download time. So notice that it's not asking for the median itself, just the lines that are needed to find the median. Now I've already done the solution. I'm going to explain what I've done. Now the first step is to draw in the ogive. So that's the polygon that joins the bottom left to the top right corner of each column. So you can see that's what I've done there. The next step is to locate half of 160, so the median's the halfway point. Locating half of 160 on the y-axis and then drawing a horizontal line across until it strikes the ogive. And then from that point of intersection, drawing a vertical line down toward the x-axis to locate the median. Question 29C. Terry and Kim each sat 20 class tests. Terry's results on the tests are displayed in the box and whisker plot shown in Part 1. Part 1. Kim's 5-number summary for the tests is 67, 69, 71, 73, 75. Draw a box and whisker plot to display Kim's results below that of Terry's results. Now the 5-number summary is in ascending order and corresponds to the minimum score, the first quartile, the median, the third quartile, and the maximum. And it should look something like this. Part 2. What percentage of Terry's results were below 69? Now the score of 69 corresponds to Terry's median score. And the median is a number that cuts off the bottom 50% of scores from the top 50% of scores. So the answer to this part is 50%. In part 3, Terry claims that his results were better than Kim's. Is he correct? Justify your answer by referring to the summary statistics and the skewness of the distributions. Now the first point to note is the median for Terry is 69, well the median score for Terry is 69, which is lower than Kim's median of 71. And that's evident from the box and whisker plots. The next point to note is the distribution for Terry is positively skewed, while Kim's distribution is symmetrical. And that can be seen by looking at the location of the median relative to the quartiles, or the position of the quartiles, and also the minimum and maximum scores. So we can see for Terry's results, the median is pushed, well, it looks like it's pushed to the left-hand side. So much closer to the minimum score, and as well as the first quartile compared to the maximum score and the third quartile. Whereby for Kim's box and whisker plot, the median seems like it's in the middle, or midway between the quartiles and also between the minimum and the maximum scores. The next point to note is that 50% of Terry's results are greater than 69, whereas 75% of Kim's results are greater than 69. So again, referring back to the box and whisker plots, the score of 69 corresponds to the median for Terry, but it corresponds to the first quartile for Kim's box and whisker plot. So that means that 75% of Kim's results are above 69, whereby for Terry, only 50% of his results are above 69. Now Terry's range and interquartile range is 9 and 6 respectively, and that's larger than Kim's range and interquartile range, which is, I'll just move this paper up a little bit, which is 8 and 4 respectively. So the lower the range and or the interquartile range, it means the more consistent the results. So Kim's results are more consistent than Terry's. So therefore, we can conclude that Terry is not correct. Question 4. On a school report, a student's record of completing homework is graded using the following codes. So we have CUSRN, which stands for consistently, usually, sometimes, rarely, or never. What type of data is this? So in statistics, we can classify our data as either categorical or quantitative. It either involves numbers or it involves descriptions, qualities. So clearly no numbers are involved there, so it's neither C nor D, so it's not quantitative. It's categorical, but are the categories able to be ranked or placed in some order? And clearly there is an order here that we can use. So consistent could be the highest, usually sort of the next highest, so on and so on to never. So this can certainly be ranked, which means it can be ordered. And there's a word here which resembles the word order, which is the word ordinal, which means ordered or ranked. So it's option A. Question 6. The times in minutes that a large group of students spend on exercise per day are presented in the box and whisker plot. What percentage of these students spend between 40 minutes and 60 minutes per day on exercise? So a box and whisker plot divides the data into quartiles, but it's just represented graphically. So 25% spend between 10 and 40 minutes. Another 25% spend between 40 and 60 minutes. Another 25% between 60 and 90 minutes. And the top 25% spend between 90 and 120 minutes. So between 40 and 60, we have 25%. And that's option C. Question 27D. In a small business, the 7 employees earn the following wages per week. Part 1. Is the wage of $970 an outlier for this set of data? Justify your answer with calculations. So this is based on that rule, the 1.5 multiplied by the interquartile range plus Q3 determines the boundary for an outlier. So let's work out the interquartile range first. So, there's 7 employees, so that's nice. Here's our median. Okay. Our Q3 will be here, and this will be our Q1. Okay, so interquartile range, okay, is equal to Q3 minus Q1. Okay, and that equals 680 minus 490. Okay, so... Alright, so 680 minus 490, and we get 190. Okay, so the upper bound for an outlier, okay, is equal to, Q3 plus 1.5 multiplied by 190, okay, and that equals, so 680 plus 1.5 multiplied by 190, and we get 965. But $970 is greater than 965, so 965 will be a little bit further to the left than the 970. So 970 will be an outlier. Now, is bigger than 965, therefore $970 is an outlier. So part 2, each employee receives a $20 pay increase. What effect will this have on the standard deviation? So looking at the original numbers, the standard deviation measures the average distance from the mean, or wherever the mean may be. But it also measures the distance or the relative difference between the points as well. So you can sort of think of it from that perspective, that if everybody got exactly the same increase, relative to each other, they're all still spaced the same. So everything has increased by $20, including the mean. So there's no effect. Okay, so there's no effect whatsoever. Okay, since they've all increased exactly the same way. Question 29D. Data from 200 recent house sales are grouped into class intervals and a cumulative frequency histogram is drawn. Part 1. Use the graph to estimate the median house price. So we have a frequency of 200. So the median would be the halfway mark. So it'll be where the 100 is. So where the frequency is 100. So what we'll do is we'll just project across first. So where on the y-axis where it's 100, we'll just draw a horizontal line across. Okay. And then what we'll do is that we'll draw part of the ogive on the third column, because clearly that's where it's going to intersect with the horizontal line that we just drew. So, okay, so we'll just do that there. Okay. And where these two lines intersect, that's an estimate of the median. So we could actually use this part of the grid here where it's visible. Okay, so we need, that's our point of intersection just there. Okay, and it's going to be roughly, okay, and like I said, it is just an estimate, so it doesn't have to be super accurate, but you know, sort of accurate enough for our purposes. So something along those lines there. So I'll just zoom in a little bit further on that. Okay, so we need to estimate roughly what this point is here. So, okay, if that's 390 to 400, why don't we just measure that? How many centimeters that is. So that's 15 millimeters, and we've gone 4 millimeters in there from the 390 mark. So, okay, so that would be, okay, so 15 millimeters is equivalent to about equivalent to $10,000. Okay, so 10,000 divided by 15 millimeters. So that's the dollar, sort of the value per millimeter on the x-axis. Multiply that by 4, and we then add that to 390. Okay. And we get around $393,000. Okay, so basically the working out predominantly is on the graph itself. Okay, so as long as you show those lines, that's generally sufficient. It's only worth 1 mark, so as long as you get the right answer, that's fine. So part 2, by completing the table, calculate the mean house price. So we need to basically convert this cumulative frequency graph into just a histogram, a frequency histogram. So I think this first column here, so this first class, so this is the 370 to 380 class. So let's write down the class center. So that's going to be the 375,000 sort of that group, $375,000 value group. Okay, and then the next one will be 385,000, 395,000, and then 405,000. So I might as well fill out this table. So 375, 385, 395, and then we've got 405,000. So just be mindful so that these numbers represent thousands of dollars. Now let's fill in the frequency column. Okay, so we know that the total's got to be 200 if we add up all the frequencies. So we know that the first class, okay, of house sales, okay, the $375,000 class, okay, there's the frequency there. So it's going up in tens, isn't it? So 50, 60, 70, 80, 90. So each of these little squares represents 10, a frequency of 10. Okay, so that'll be that's 40 there. Okay, so that'll be, actually no, that'll be 0. So 10, 20, 30, 40, 50. Yep, so that'll be the 0. So just be careful. The x-axis, just because of that symbol there, the x-axis does not start at 0, but the y-axis does. So just be very careful there. Okay, so to be mindful of that. Okay, so we've got 10, 20, 30. Okay. So this is where a lot of the work is, in fact. So there's 30 homes or 30 houses at that in that class. Now the next one along, so this class here, that's 80. Okay. But the frequency is not 80. That's the cumulative frequency. That also includes the 30. So it's going to be 80 minus 30. So that'll be 50. Okay. Now the 395. So that's this column here. Okay, that's 150. That'll be 150, 150 minus 80. Okay, that'll be 70. So we'll fill that in here. And the last one, well, we know it's 200. So in total, 200 minus 30 minus 50 minus 70. And just fix that quickly. And we get 50 as well. So... okay, now to work out an estimate of the mean or the mean house price, we can create a sort of an FX column there, and we can just multiply these together, these two columns together. So 375. Now remember, this is thousands of dollars multiplied by 30. Okay, and we get 1, 1, 2, 5, 1, 2, 3, 4. Okay, the next one along, okay, is the 385. Okay. And that occurs 50 times. Okay, 1925, 1, 2, 3, 4. Okay, I've just chosen to write the answers there in full. Okay, it's just easier to work with. Okay, 395, and that occurs 70 times, and we get 2765, 2765, 1, 2, 3, 4, and then we got 405 times 50, 405,000, and there's 50 of those, 2025. Okay, so the mean is we add up the FX column and then we divide it by the frequency. Okay, so mean is equal to the sum of the FX column, so 1, 1, 2, 5, 0, 0, 0, 0, plus 1, 9, 2, 5, 0, 0, 0, 0, plus 2, 7, 6, 5, 0, 0, 0, 0, plus 2, 0, 2, 5, 0, 0, 0, 0, and we're going to divide that by 200. Okay, and that'll be the mean. So let's do that. Okay, so 1, 1, 2, 5, 1, 2, 3, 4, plus 1, 9, 2, 5, 1, 2, 3, 4, plus 2, 7, 6, 5, 1, 2, 3, 4, plus 2, 0, 2, 5, 1, 2, 3, 4, 4 zeros. Divide that by 200, and we get 392,000 as our mean house price based on that data. Question 7. Which set of data is classified as categorical and nominal? Categorical means there's no numbers involved. So it cannot be option C and it cannot be option D. So between A and B, you can see the types of data that we have there. One of these can be ordered, one of these cannot. Nominal means in name only. It comes from French. NOM means nom, nom means name, name only, option A. The other one is ordinal. Ordinal means that it's categorical data that can be arranged in some sort of order, and that's option B, obviously. So option A is certainly the answer here. Question 19. A soccer referee wrote down the number of goals scored in 9 different games during the season. The last number has been omitted. The range of the data is 10. What is the 5-number summary for this data set? So the first clue as to what the last number is the range. The range of the data is 10. That's the difference between the lowest score and the highest score. So the highest score must be 12. Now that immediately eliminates option B and option D. So the other thing we need is the median. 1, 2, 3, 4, 1, 2, 3, 4. So the median is 5. Now it just so happens that all of them, the median is 5. Okay, so we need the quartiles. So the lower quartile is 3. Okay, so Q1 is equal to 3, so that's between this number and this number there, this score there. And between 8 and 9 is Q3, and that's going to be 8.5. So the only other option that has 8.5 in it is option A. So this is our 5-number summary. Question 21. A group data frequency table is shown. What is the mean for this set of data? Now, first thing we need to do is to work out the center of each of these class intervals, which is the average of each of the two endpoints. So the average of 1 and 5 is 3. Okay, add the 2 and divide by 2. The average of 6 and 10 is 8. Average of 11 and 15 is 13. And the average of 16 and 20 is 18. So just the midway point. Now, we can either use the stat mode on the calculator, okay, and that probably might be the easiest option. Might take a little bit longer, but it's probably the safer option. Now notice with the calculator that you don't have the frequency column. Quickly shift setup, scroll down, stat number 4, frequency on. So let's enter in the data, 8, 13, and 18. And the frequency 3, 6, 8, and 9. AC, shift, stat, and var number 4 and number 2 x bar. And we get 12.42. So that's going to be option D. Question 22. The box and whisker plots show the results of a history test and a geography test. In history, 112 students completed the test. The number of students who scored above 30 marks was the same for the history test and the geography test. How many students completed the geography test? So let's have a look at the history box and whisker plot. Okay, and let's have a look how many students scored above 30, because it's the same for geography as well. So that's the upper whisker, okay, which represents the upper 25%. So 112 multiplied by 25%, because we're only talking about this region here. Okay, so 112 multiplied by 25%, and we get 28 students. Okay, so we also know that, obviously based on the question or the information given, that the same number of students also scored 30 in the geography test. So from here to here, okay, or to the tail, sorry, that's also 28 students. But that's from the median to the maximum score. But the median represents the 50% mark. So the number of students that in total that completed the geography test, okay, is 28 multiplied by 2. Okay, so it's from the median up, we want the median down, and that's equal to 56. So 56 students sat the geography test. Option C. Question 27b. A small population consists of 3 students of heights 153 centimeters, 168 centimeters, and 174 centimeters. Samples of varying sizes can be taken from this population. What is the mean of the mean heights of all the possible samples? Justify your answer. So we're talking about a tiny population here. So it's a population of 3. And the samples that can be taken from this population, you can either take all 3, so all 3 students, 153, 168, 174. We can take samples of 2 students, so it could be 153, 168, 153, 174, or 168, 174, or we can just take samples of 1 student. So 2 ways we can do this. We can either just sort of work out all the different possibilities, add them together and divide by the number of possibilities, or we can apply the theory that the mean heights of all the possible samples is in fact equal to the mean of the population itself. Okay, so in fact I'm going to do it both ways just so you can see this. I'm going to take a little bit longer with this question. So let's just work out the mean of the mean heights by using that theory that it's just that's just the mean of the population itself. So 153 plus 168 plus 174 all over 3, okay, we get, just enter this in, plus 168 plus 174 over 3, get 165 centimeters. Okay, so I'll just make a point of that. That's the mean of the means. But let's just show all the different possibilities. So just for just to sort of help your understanding a little bit. Okay, so I'm going to do this actually at the bottom here because it's not really part of the solution, but I think it's good to know. So let's have a look at the various possibilities. Okay, we have 153, so we can take a sample of one student, and the mean of one student, the mean of 153 is just 153, the mean of 168 is 168, and of course the mean of 174 is just 174. Now, what about samples of 2? So we've got 153 plus 168 over 2 plus 153 plus 174 over 2. So these are all the different possibilities, plus 168 plus 174 over 2. So these are sample sizes of 2 plus the mean of, taking a sample of 3 from this population of 3. So in fact that's going to be 153 plus 168 plus 174 over 3. Okay, all that divided by the number of samples, 1, 2, 3, 4, 5, 6, 7. So let's divide all that by 7 and let's see if we get 165. So, okay, right, 153 plus 168 plus 174 plus, we've got 153 plus 168 over 2 plus 153 plus 174 over 2 plus 168 plus 174 all over 2 plus 153 plus 168 plus 174 over 3, since it's a sample size of 3. Now these are all the means, and let's divide all that by 7. And we get 165. So, at least in this instance, this theorem, or this applying this theory that the means of all the possible samples, we could just work it out by just taking the mean of the population itself. Question 27C. The heights of 400 students were measured. The results are displayed in this cumulative frequency polygon. Use the polygon to estimate the interquartile range. So let's work out where the first quartile is, or the lower quartile. So that's going to be a quarter of 400, which is at 100. Okay, so that's our Q1. And we need the upper quartile, or Q3, which is 3/4 of 400, which is 300. So there's our Q3, and the interquartile range is obviously the difference between the two, and it's not 200. We need to project across, okay, so to there, and then project down. Okay, so that's Q3. Okay, and we need Q1, which is just there, projecting down. Okay, and this one is Q1. So let's work out the value of Q1. So 1, 2, 3, 4, 5. So it looks like it's going up in 2s. So 132, 134, 136 centimeters. And Q3 is 172. Okay. So interquartile range. Okay, is equal to Q3 minus Q1, which is equal to 172 minus 136. Okay. So 172 minus 136 equals 36 centimeters. Question 29C. The ages of members of a dance class are shown in the back-to-back stem and leaf plot. Pat claims that the women who attend the dance class are generally older than the men. Is Pat correct? Justify your answer by referring to the median and skewness of the two sets of data. So I think just looking at the two stem and leaf plots, I think we can see that the plot that represents the women tends to be negatively skewed. So more of the data tends to be at the upper end, whereby with men tends to be positively skewed. So I might just draw just a curve around that, around the stem and leaf plot, and with the stem and leaf plot that represents women, we can see that the tail is toward the negative end, the lower end where the lower numbers are. So clearly negatively skewed, right? So I'm just gonna write a few notes there. This one is positively skewed. Okay, so now let's work out the median. So the median's the middle score. So how many scores have we got? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the median, okay, for women is equal to the 7th score. So 1, 2, 3, 4, 5, 6, 7, it's 55. So the median for the group representing men, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be the 5th score. So 1, 2, 3, 4, 5. So that's 45. Okay, so we can clearly see that the median age for men is 10 years younger than the median age for women. And the shape of the distribution, the skewness, okay, is negatively skewed. Okay. And the skewness for men is positive. In other words, the bulk of the scores are on the lower end of the distribution. In fact, if I hold it like that, you can see that there's a tail and toward the positive side there. Okay. So we got those two. I think there's one more thing that we can add as well. Perhaps, not that we have to, but I think it's good to note that the modal class for men is lower than the modal class for women. So, okay. The modal class is 50 to 50, that group, that range 50 to 59, and the modal class for men is 40 to 49, that age group. Okay, so the modal age group. Okay, so I think Pat's correct. I think based on that, okay, since the median age for women is 10 years higher than the median age for men, okay. Also, the skewness for women's ages is negative, while men's ages, skewness for men's ages is positive, which implies that more of the men are younger. Okay, we've run out of space here, so I could continue writing on and on, but I think that's enough. I mean, I just added the modal class here just as an extra observation. I don't necessarily need to use it, but it could be worth something, and I think it's certainly worth noting. Question 1. The box and whisker plot for a set of data is shown. What is the median of this set of data? So the median is this line that's inside the box. Points to 30, option C, median is 30. Question 4. A factory's quality control department has tested every 50th item produced for possible defects. What type of sampling has been used? Let's have a look at the options. Quantitative is not a type of sampling, that's a type of data. So it's certainly not D. We're testing every 50th item, so there's nothing random about that. So it's certainly not A. Stratified, well, that implies that we're surveying or sampling data from a large group that is composed of smaller groups, such as, for example, year groups in a school. It's got nothing to do with that. There seems to be a pattern here. It's every 50th item. So when there's a pattern in the sampling, we tend to call that systematic. So it's option C. Question 26F. The area chart shows the number of goals scored by 3 hockey teams, A, B, and C, in the first 4 rounds. So part 1, how many goals were scored by team C in round 1? So let's locate round 1. So that's this first label there, round 1. Now, along the y-axis, measuring how many goals are scored by a particular team is really the difference between that particular team and the team before it. That's how we read an area chart. So if looking at team C, we can see that that's 9 goals here, but it's actually not 9 goals overall. You've got to subtract 5 from that. So 9 minus 5, that gap gives you the number of goals scored. So 9 minus 5 is equal to 4 goals scored. Okay, so we're talking about this gap here is 4. Part 2, in which round did all 3 teams score the same number of goals? So that implies then that the gap between all these teams and also including the x-axis should be identical. And I'm looking straight at round 3. You could just sort of see it there that the gap between the x-axis and team A is 2. Between team A and B is 2 as well, 2 goals. And between B and C is also 2 goals. So 2, 2, 2. In which round? Round 3. And that's it. Question 27A. Jamal surveyed 8 households in his street. He asked them how many kilolitres of water they used in the last year. Here are the results. Part 1, calculate the mean of this set of data. And part 2, what is the standard deviation of this set of data correct to 1 decimal place? So we can use stat mode for this. So just brighten that display a little bit. Press mode, mode 2, stat, and then 1 var. So option 1. Let's enter in this data. So 220, 105, 101, 450, 37, 338, 151, and 205. Press AC. Now shift 1, okay, that brings up the stat menu, and we go option 4, so press that. Okay, so option 2 now is X bar, so that's the mean, and it's going to be 200.875 kilolitres, and the standard deviation, shift 1, option 4, var, and option 3. Press equals, and that's going to be 127.357. Just make sure that we round this correctly. It says to 1 decimal place, so that's equal to 127.4 kilolitres. Question 30A. A set of data has a lower quartile, QL, of 10 and an upper quartile, QU, of 16. What is the maximum possible range for this set of data if there are no outliers? So this is a question that's based on the formula 1.5 multiplied by the interquartile range, subtracted from QL or added to QU, and that finds the boundaries for the outliers. I might just draw a quick diagram just to show you what I mean. So imagine, here's our number line. There's QL, and there's QU. Okay, this is the interquartile range. All right, basically from QL to QU. Now, if you multiply this by 1.5, okay, this interquartile range, and you add it to QU, okay, so adding this to QU, or you're subtracting this from QL, this gives you the boundaries of the outliers beyond these boundaries. So the first thing we need to work out is the interquartile range. Okay, and that's QU minus QL, so it's going to be 16 minus 10, okay, which equals to 6. Now let's work out 1.5 multiplied by the interquartile range, okay, and that's equal to 6 multiplied by 1.5, which is equal to 9. Now the outlier boundary, okay, and let's work out the lower one. Okay, so that's going to be QL minus 1.5 multiplied by the interquartile range. QL is 10. Okay, so we've got 10 to 16. So 10 minus 9, which equals to 1. And QU plus 1.5 multiplied by the interquartile range. QU is 16. So 16 plus 9, which equals to 25. So the range, which is what the question's asking, the maximum possible range, okay, so I'll just put here, right, the max range is equal to 25 minus 1. Right, where there are no outliers. Question 1. A set of scores has the following 5-number summary. What is the range? Now the range is equal to the maximum score minus the minimum score. So this is our maximum score, 9 minus 2, which equals 7, option D. Question 3. A survey asked the following question. How many brothers do you have? How would the responses be classified? So how many indicates we're counting something. So it's most certainly not categorical data that we're looking for. It's definitely quantitative. And we're talking about counting people. So we're talking about a whole number of people, not fractions of a person. So it certainly cannot be continuous. And so the answer is C, quantitative and discrete, because we're counting whole numbers. Question 6. A set of data is displayed in this dot plot. Which of the following best describes this set of data? Symmetrical? Certainly not. So it's not A. Nor is it normally distributed, because we'd expect a bell curve. So it's not D either. So it's either positively skewed, negatively skewed. We look and see where the tail is. The tail is on the negative side or on the left-hand side. So the answer is negatively skewed. Question 11. A set of data is summarized in this frequency distribution table. Which of the following is true about the data? So the first thing we need to work out is the mode. And the mode is the score that has the highest frequency, which is going to be 7. So there's our mode. So it clearly cannot be option C and it cannot be option D. Now to work out the median, you can either add a cumulative frequency column, but there's probably under pressure, there's a reasonable chance that you may get that wrong. Or you could just quickly use stat mode if you're fairly quick at that. And I'm just going to enter that in quickly, 3, 4, 5, 6, 7, 8, and then just enter in the frequency. So 1, 2, 6, 7, 9, and 5. Shift 1, min max 5, median number 4, answer 6. So it's going to be option B. Question 17. The area chart shows the number of students involved in tennis or cricket at a school over a number of years. In which year was the number of students involved in tennis equal to the number of students involved in cricket? So let's have a look at 2013. We have 40 students involved in cricket, but only 10 involved in tennis. So what we're looking for is the distance from the x-axis to the first line equal to the distance from the first line to the second line. And in fact, that's going to happen at 2015. We have 30 students here for cricket, and then counting from the line that represents cricket up to the line that represents tennis, there's another 30 students there. So the answer is option C, 2015. Question 26D. The graph displays the mean monthly rainfall in Sydney and Perth. So part 1. For how many months is the mean monthly rainfall higher in Perth than in Sydney? So we'll look for the bar that represents Perth. We'll look for the months where the bar that represents Perth is higher than the bar that represents Sydney. So certainly not January, February, March, April, May, June. In July, Perth's higher, August, and also September. So we have 3 months. So for part 2, for which of the two cities is the standard deviation of the mean monthly rainfall smaller? Justify your answer without calculations. So a small standard deviation implies small variation. Now, if we look at Sydney, we can see that the bars for Sydney don't vary all that much compared to the bars for Perth. So there's definitely far more variation between the months with least rainfall to the months with most rainfall. So the answer for this one is Sydney. And we would say that the variation in rainfall between the lowest and highest levels is smaller than Perth's. Question 26E. A cumulative frequency table for a dataset is shown. What is the interquartile range of this dataset? So this solution is different to the solution in the NESA marking guide. So just an alternative way of solving or entering this problem. What I'm going to do is I'm going to create a frequency column and convert the cumulative frequencies into the frequencies for each score. Score 1 occurs 5 times. The score 2 occurs 9 minus 5 times, which is 4 times. The score 3 occurs 16 minus 9 times, which occurs 7 times. The score 4 occurs 20 minus 16 times, which occurs 4 times. The score 5 occurs 34 minus 20 times, which is 14. And the score 6 occurs 42 minus 34 times, which is 8. Now what we're going to do is just use the stat mode on the calculator to just enter in the frequency table. So 1, 2, 3, 4, 5, 6. And then entering in the frequencies 5, 4, 7, 4, 14, and 8. Now shift 1 will get it into the min-max menu. Q3, 5. And then we'll work out Q1, min-max, Q1, 3. And we get 3. Therefore, the interquartile range is equal to 5 minus 3, which equals to 2. Question 10. A school collected data related to the reasons given by students for arriving late. The Pareto chart shows the data collected. The way we're going to answer this question is we're going to use the cumulative frequency polygon. We're going to look at train or bus delay. Now, at this point here, this is 92%. But because it's cumulative, this includes all the other reasons in front of it as well. So this includes sleeping in, family, and appointment. So we can't include these three columns. This point here is 86%. And this 86% refers to appointment, family, and sleeping in combined. So 92% minus 86% will give you the percentage contributed by just train or bus delay alone, and that'll be 6%, which is option A. Now, the other way you could do this is to add up all the columns individually, get a total, and then divide train or bus delay by the sum of all these columns, but that'll take you a lot longer. It's much quicker to use the cumulative frequency polygon and just understand that it is cumulative, which means that if you take a point and subtract the point before it, that'll give you the percentage contributed for that particular reason. Question 19. The heights in centimeters of 10 players on a basketball team are as shown. Is the height of the shortest player on the team considered an outlier? Justify your answer with calculations. First thing to note, if you look at the scores, they're listed in ascending order. Second thing is we're dealing with outliers, which means that we want to determine whether 170, the shortest player on the team, is considered an outlier or not. So we need to calculate where the boundary for an outlier would lie, and that is related to the quartiles, the Q3 and Q1. So it's actually related to Q1, the lower quartile. And we need to work out how far below the lower quartile we need to go before a score then is considered an outlier. So let's work out where the quartiles are first. Okay, so there's 10 scores. 1, 2, 3, 4, 5. So the median, which we need to work out first, is between the 5th and 6th scores. So between 192 and 193. So the median is there. Okay, and this is 192.5. Let's have a look at the bottom 5 scores. The median of the bottom 5 scores is 185. So that's our Q1. The median of the upper 5 scores is Q3, which is 194. Now we need to work out the interquartile range, because now we're sort of on our way to calculating this boundary value. Okay, so outside of which a score is then considered an outlier. Okay, so first of all, interquartile range is equal to Q3 minus Q1. Okay. Interquartile range is equal to 194 minus 185, and that's equal to 9. Next thing we need to calculate is the lower boundary for an outlier. Okay. Is equal to, it's actually equal to Q1 minus 1.5 multiplied by the interquartile range. Okay, so Q1 is 185 minus 1.5 multiplied by the interquartile range, which is 9. So let's calculate what that lower boundary is. Okay, so 185 minus 1.5 multiplied by 9, and we get 171.5 centimeters. Now, the shortest player is 170 centimeters. Which is less than 171.5 centimeters. Therefore, is considered 170 centimeters is considered an outlier. Question 39. Two netball teams, Team A and Team B, each played 15 games in a tournament. For each team, the number of goals scored in each game was recorded. The frequency table shows the data for Team A. The data for Team B was analysed to create the box plot shown. Compare the distributions of the number of goals scored by the two teams. Support your answer with the construction of a box plot for the data for Team A. So the first thing we're going to do is generate our 5-number summary. Now, straight away, the minimum score for Team A, I might just write it here on the side. So min score is equal to 19. We need the first quartile, we need the median, we need the third quartile, and we need the max score. And we know what the max score is, it's 28. We're going to use these 5 numbers to draw our box plot for Team A. So first thing we're going to do is put our calculator into stat mode. So mode 2 and then 1 var. Now notice that we need a frequency column. So shift, mode setup, okay, scroll down, STAT number 3 and then frequency on. Right, now let's enter in the data. So what I'm going to do is I'm going to enter in one column at a time. So 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So they're the scores. Let's enter in now the frequencies associated with those scores. So 19 is 1, 20 is 0, 21 is 1, 22 is 1, 23 is 1, 24 is 3, so let's enter in 3, 25 is 0, 26 is 4, 27 is 3, 28 is 1. So one thing I do just very quickly is just check to make sure that they're entered in okay or accurately. 19, 20, 0, 21, 1, 22, 1, 23, 1, 24, 3, 25, 0, 26 should be 4, 27 should be 3, 28 should be 1, so that looks okay. All right, so we know what our min and max are. Let's generate quartile 1 and median and quartile 3. Shift 1, min max, number 5, number 3, Q1 equals 23. Now, median, shift 1, min max, number 5, median, number 4 there, 26. Now the third quartile, min max, number 5, quartile 3, number 5 there, and we've got 27. We now have the data that we need to draw our box plot. So minimum score is 19, so I might just put a little dot there. Okay, quartile 1 is 23, median is 26, okay, quartile 3 is 27, and the maximum score is 28. So, okay, now let's draw it in. So, okay, so we'll draw in the tails. Okay, now we'll draw in the box. Okay, please use a ruler to do this. And our median line. Okay, so a grid's provided, does make it a lot easier to draw in. So there you go. There's our completed box plot for Team A. Let's analyze this quickly. First of all, we can see that the interquartile range, okay, hopefully you can see that, interquartile range for Team A is less than Team B, which means Team A is more consistent. Okay. Next thing to note is that the positioning of the two boxes, including their medians, Team A's box, okay, with their median is lower than the box for Team B. Okay, so that's which implies Team A performed, or we can say that Team A did not perform as well as Team B. Okay, something else to note as well is look at the whisker for Team A. It's clearly much longer than the whisker for Team B. So, and also the positioning of the median as well. So this implies that Team A's, the distribution for the scores of Team A is negatively skewed. Okay, so all right, so the lower tail is much longer than the upper tail for Team A, which implies a negatively skewed distribution. So that means potentially it could be a few players that, might not be doing so well. Okay, whereby Team B shows a symmetrical distribution according to their box and whisker plot to the similar length whiskers. And the centrally located median. I've gone slightly over there, but I think that's fairly comprehensive. Question 7. Which histogram best represents a data set that is positively skewed? So that's a distribution that has what we call a tail. So it seems to be sort of very long on one side of the distribution. So if you have a look at A, okay, the bulk of the distribution is on the left-hand side, but there's a tail region on the right. Option B is the other way around. So you got the tail on the left, okay, so it sort of looks like that, and we don't want that because that's negatively skewed. So it really goes by where the tail is or the position of the tail. C is somewhat symmetrical, okay, and D is sort of somewhat uniform. So it's option A. Question 28. Consider the following data set. So we have a 1, 5, 9, 10, 15. Suppose a new value, x, is added to this data set giving the following. So 1, 5, 9, 10, 15, and this x added to the end. It is known that x is greater than 15. It is also known that the difference between the means of the two data sets is equal to 10 times the difference between the medians of the two data sets. Calculate the value of x. So I dare say that the difficulty in this question is more trying to unpack this last paragraph here. So let's work backwards. So we're talking about the difference between the medians of the two data sets. Then we'll consider 10 times the difference, and then we'll use that to compute the mean of the second data set, and from that we can then calculate the x. So what I'm going to do is I'm just going to label these two data sets. Okay, so let's call this data set A and let's call this one data set B. Okay, so median of A is equal to 9. Okay, so thankfully it's an ordered set of scores. Okay, and let's have a look at the median of B. Okay, and there's 6 scores, so it's an even number, so it's going to be between 9 and 10, so it's going to be 9.5. Okay, so the difference between the medians is 9.5 minus 9, which is equal to 0.5. Okay. Now we need 10 times the difference between the medians. So we have the difference between the medians. Let's work out 10 times the difference. Which equals 5. Okay. So continuing to work backwards, it is known that the difference between the means of the 2 data sets is equal to 10 times the difference. Now we have 10 times the difference here. So let's work out the means of the 2 data sets. So the mean of data set A is simple enough to compute. Okay, and we have 1 plus 5 plus 9 plus 10 plus 15 divided by 5. Okay, so I'm not going to use the stat mode on the calculator. I think it's just quicker to just add them up manually and divide that by 5, and we get 8. Okay. Now, the mean of data set B, okay, now this one has the X in it. Let's go back to this paragraph here. It is known that the difference between the means is equal to 10 times the difference. Now, 10 times the difference is 5 between the 2 medians. If the mean of data set A is 8, therefore the mean of data set B must be 8 plus 5, which must be 13. Now, from that, we should be able to deduce the value of X. Okay, so what? 1 plus 5 plus 9 plus 10 plus 15 plus X, if we divide that by 6, because there are 6 scores, so we're finding the average, and we know what the average is, so we're kind of working backwards yet again, and it's equal to 13, since we know that the mean of data set B is 13, since that's what we've deduced already. So let's multiply both sides by 6. Okay, we can add these 5 scores as well. So I'll just do this in a few steps. So 1 plus 5 plus 9 plus 10 plus 15 plus X is equal to 13 times 6, so that's going to equal to 78. Okay, so therefore X is equal to 78. And if we subtract all these numbers, look, I could just add them up first and then subtract it from 78, but I might just do this. -1, minus 5, minus 9, minus 10, minus 15, and that'll give us our value of x. So 78 minus 1, minus 5, minus 9, minus 10, minus 15. And the value of x there is 38. Question 36. A cricket is an insect. The male cricket produces a chirping sound. A scientist wants to explore the relationship between the temperature in degrees Celsius and the number of cricket chirps heard in a 15-second time interval. Once a day for 20 days, the scientist collects data. Based on the 20 data points, the scientist provides the information below. A box plot of the temperature data is shown. There's your box plot. We have the mean temperature in the data set is 0.525 degrees Celsius below the median temperature in the data set. A total of 684 chirps was counted when collecting the 20 data points. The scientist fits a least squares regression line using the data, xy, where x is the temperature in degrees Celsius and y is the number of chirps heard in a 15-second time interval. The equation of this line is y equals negative 10.6063 plus bx, where b is the slope of the regression line. The least squares regression line passes through the point x bar, y bar, where x bar is the sample mean of the temperature data and y bar is the sample mean of the chirp data. So this continues on the next page. Calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius and give your answer correct to the nearest whole number. There's a lot going on in this question. So, let's work backwards. We want to work out or calculate the number of chirps expected in a 15-second time interval when the temperature is 19 degrees Celsius. Going back to our equation of the regression line, it hinges on this. We need to find the value of b, or the gradient of the line. Now, working backwards even further, in order to get or to calculate b, we need x bar and y bar. Now, x bar is the average temperature. Let's go to the box and whisker plot. One of the points here is, or the second point is, that the mean temperature in the data set is 0.525 degrees Celsius below the median temperature in the data set. So let's see what the median temperature is then. It's 22. So it's important that you understand how to read a box and whisker plot and know where the median is. So let's start off. So what I'm going to do is I'm going to write down that the median temperature is equal to 22 degrees Celsius. Now the mean temperature is 0.525 degrees Celsius below that. So let's write that down. So the mean temperature, which is equal to x bar, is equal to 22 degrees minus 0.525. Okay. And we get 21.475. So this is x bar that we will need to use in order to be able to calculate the slope of the regression line b. Okay, now the next thing we need to work out is y bar. And that's the average of the chirps, okay, or the sample mean of the chirp data, okay, in a 15-second interval. And the third point, so let's make sure we get the points, the number of points correct, first, second, third point. The third point will give us y bar. Okay, we have 684 chirps was counted when collecting the 20 data points. So let's work out the mean chirp data. What's the mean number of chirps actually in a 15-second interval? And that's in fact equal to y bar, which is equal to 684 divided by 20. Okay, so 684 divided by 20, and we get 34.2. Now, let's go to our regression line, okay, or the equation of the regression line. We know, and we're actually told, that the regression line passes through this particular point, x bar, y bar. Okay, so the regression line I'll just write the equation again, just makes it easier. So it's y equals negative 10.6063 plus bx passes through the point 21.475, that's our x bar, and y bar is 34.2. Now we need to substitute this coordinate or this point into the regression line equation. So 34.2 is equal to negative 10.6063 plus b times x, or x bar, which is 21.475. Okay, so rearranging that equation, okay, we have 34.2, we're going to add on 10.6063. I'm going to put that in brackets. I'm going to do this all in one step. And then we're going to divide by 21.475. So this is just a little bit of algebra. 21.475. Okay, that's equal to our gradient. So therefore, b is equal to, okay, let's work that out now. So 34.2 plus 10.6063. Divide that by 21.475, and we get 2.086. I might just write the whole answer there rather than rounding it too early. 0.86440047. Now that we have the gradient of the line, we can now use this to, in fact, answer the question. So we want to work out how many, or calculate the number of chirps in a 15-second interval when their temperature is 19 degrees. So now, at x equals 19, okay, we have y is equal to negative 10.6063 plus 2.086440047 multiplied by x, which is 19. Okay. So working that out, we have negative 10.6063. Now, the value for b is in the answer memory, so I'm just going to use that. So just be very careful using that to make sure that that's in fact the correct value that you have in there, as long as you haven't done any other calculation. Times 19, and we have 29.036. Now to correct to the nearest whole number, we have 29 chirps. Thank you for watching.